Well, thank you, Sir Martin. I have to say, it is an honour to share the platform with Sir Martin Sweeting. He doesn't know this. We've only known each other for about 2.5, 3 years now, but he's been one of the inspirations from afar to me for a long time. And as this project began, the project I'm going to talk to you about tonight, Virgin Galactic, it was the inspiration of what Surrey achieved that has kept us going through some of the early phases of this project. It's been truly a remarkable experience, and you're a remarkable man, sir, so thank you. Now, tonight, I'm going to do that thing you never do at a lecture. I'm going to show you a short video, and normally they're about 20 minutes long and everybody gets very bored. But actually, there's some pretty exciting footage in this one. It's a brief introduction to Virgin Galactic by Sir Richard Branson, which is what a customer who's bought a ticket first sees when they buy that ticket. So we can run the short 5-minute film, and then I'll be telling you a little bit about the background to this after it's over. Well, I hope I'm going to be able to do that. Here it comes.
3, 2, 1, release.
I absolutely have to develop a manned space tourism system that's a...
This is going to catch hold like a wildfire. We have never seen space.
It's absolutely crucial. It's our communications, it's our logistic provide.
It's pretty memorable as well, especially ignition.
I'm part of something that history is going to be making.
What we are experiencing will be the greatest emotional event of our lives.
You know, Richard, to do it right, he's just an incredible entrepreneur and a very spectacular...
The important thing about today's accomplishment is this is not an end, it's just a very good beginning.
This will be a trip like no other, and will give those that travel with us a unique and life-changing perspective of our planet. For most of us, escaping the constraints of gravity is something we've only been able to achieve in our dreams. Until now. Virgin Galactic is now on the final stretch to becoming the world's first commercial space line. Our suborbital space trips promise to be the most intense and wonderful experiences that our passengers have ever had. Our spacecraft have been designed so that each of our passengers will have the room and the freedom to enjoy the amazing sensation of weightlessness. Large panoramic windows will allow you to see clearly the curved Earth over 100 kilometers below, and the colors of the fragile atmosphere protecting our vulnerable planet. We had spent many years on a frankly fairly futile search for technology that could be developed into a vehicle which would meet our specifications for safety, environmental impact, and commercial viability, and of course the potential for a great customer experience. But Rutan Spaceship One and those flawless history-making X-Prize flights in 2004 suddenly changed all that, and we grabbed the opportunity.
We showed that it is feasible for industry to develop and fly manned spacecraft. But the more important thing is that what we did on our program is to develop safety solutions. Spaceship Two has a unique feathering configuration, and what that does, it allows it to re-enter the atmosphere in a carefree fashion. It can come into the atmosphere at any angle and it'll straighten itself out without the pilot having to fly that or without a computer having to do it.
You can then change the shape of the ship at 50,000 feet back into a normal glider and land on a normal runway, as people would do in the seas environment of a normal aircraft.
Well, the day that Bert won the X-Prize was a hugely significant one for us. I remember chatting to Brian Binney, the pilot on that epic flight.
The vibrations go away, the shrieking and shrilling noise of that rocket motor disappears, and you get this instant karma of weightlessness. You cannot appreciate the experience just by looking at a magazine cover, just what it is like to take it in with your own eyes.
Since the announcement in 2004, the project has reached and passed many important milestones. We have a truly inspiring design for our home at Spaceport America in New Mexico, an ever-increasing family of pioneering customers, and of course, beautiful new vehicles now in an extensive test program before they start commercial service. Our first Virgin Galactic astronauts are booking their own place in history as pioneers of a new space age, and for them the journey has already started. Like many of our fellow future astronauts, I've already completed my centrifuge experience with my son. It was an incredible ride and great preparation that really brought home to us just how awe-inspiring it will be at that moment when the Virgin spaceship is released from the Virgin mothership and starts its supersonic climb to space. Already, Virgin Galactic's carrier aircraft, White Knight 2, is the world's largest all-carbon composite aircraft. With the end of the oil era approaching and climate change progressing faster than most models have been predicting, safer, cheaper and more flexible access to space is essential.
Access to space really does matter for the future of mankind, and currently we only have 50-year-old space systems to get there, which are very expensive and very environmentally damaging.
Well, I hope you will be as excited and inspired by Virgin Galactic's mission as I am. And see you up there.
How did a record company and an airline come to get involved in that little caper? That's a pretty inspiring film if you think about what's been achieved in a very short space of time by Burt Rutan with Paul Allen's backing, and subsequently by Sir Richard deciding to back us as a team to develop a commercial business. Now, the background to Virgin is really quite a different background to most companies, and it's a background that has allowed this project to happen, whereas many other organisations in the commercial sector wouldn't have allowed that to happen. For a start, we think of ourselves as a branded venture capital organisation. We don't think of ourselves as a company. We think of ourselves as a brand standing for things and doing things. And I think that stood us in good stead through this project. We also have a very strong philosophical background developed as part of what was called the Gaia Capitalism Project, inspired by actually my other hero in the world, Professor James Lovelock. He inspired Richard to think about the way we would manage our businesses, and it began in 1998, the Gaia Capitalism Project. And basically, we believe that the impact of peak oil and human-induced climate change is going to be the driver of company performance over the next 3 or 4 decades. And we don't believe that buying carbon offsets by businesses is a way to get involved in providing a more efficient structure for future businesses in this climate. We think the losers will be the people who buy carbon credits. We also think that the winners will be the people who become the most carbon-efficient companies in the world. And that has inspired what we've been doing with all the Virgin businesses over the past few years. We also think that this is a survival issue for both our business and a lot of other businesses around the world. The $100 world oil that's mentioned in that slide, you would have seen that on a slide presented by myself 4 years ago, and I was often laughed at in audiences when I talked about $100 oil, and it's come true. It inspired really Virgin's development of a whole range of businesses that people thought we were mad to go into in 1998-9. When we went into the rail business, first of all of the commentators in British financial media and the rail media said, oh, Railtrack can build a really good railway, but Virgin can never build a train that will work, and it will go bust. Railtrack went bust 3 years later, couldn't build a railway, and we built one of the best trains operating in Europe at the moment. We were also inspired to get into that business, the rail business, because we did believe that air travel domestically was going to become more difficult and more expensive. And it's been a successful business for it. In fact, it's probably the business that is most funding Virgin Galactic at the moment. It's producing very high returns this year and will do next year as the network gets better and better and is attracting more and more passengers. However, the project that really led to the project that we're involved in today has to be the Virgin Atlantic Global Flyer project, which I had the honour to work on with Burt Rutan. Now, when you look at Spaceship 2 and White Knight 2, Spaceship 2 looks remarkably like Spaceship 1, but White Knight 2 looks remarkably more like this vehicle than White Knight 1 and White Knight 2 would have in common. And this vehicle was incredible. We built a plane when both Boeing, who have gone a long way since then, and Airbus, we began to build this plane when they said actually building 100% carbon composite high-altitude jets was decades, or a decade away at least. And Burt built this thing in about 15 months. And between Steve Fossett, who flew it around the world and got the world record for the first ever solo circumnavigation, and ourselves, who sponsored it because we wanted to understand carbon composite technologies and what they might be able to do to the environmental impact of aircraft, between ourselves and Steve, we actually did this entire project for $8 million. you can't even actually buy seats for a 747 for $8 million, let alone buy the plane. So it was really quite an inspiring project to what the cost benefits could be of attacking the problem of access to space using carbon composite technology. And of course, there was the famous moment when myself and my colleague Alex Tye were at Bert's factory, and I was looking over the project for Virgin Atlantic and helping to look after the construction of it. And Bert decided for the first time to show us Spaceship One shrouded in a corner because he just couldn't resist it. And I had to go outside on my mobile phone, almost speechless, and I'll use the swear word, the F word a little bit. I had to say to Sir Richard, fuck, he's building a spaceship. What are we going to do? We've got to build one of these. And it was literally that kind of conversation that led to the second investment that we made with Bert. Now, the 787 for us has been part of the learning curve that has come out of the Virgin Atlantic Global Flyer. We are one of the launch customers for what will be the most carbon composite and one of the most efficient commercial aircraft yet built. And it has also, the Virgin Atlantic Global Flyer project and other projects in that Gaia Capitalism project, has led us to actually fly the first ever commercial biofuel flight in the world. And it is what has also directly led to space. Space as seen by Brian Binney on October the 4th, 2004. Space seen by Brian Binney in a $30 million project. They got 2 people into space in the space of 2 weeks. And space that made us think about the way we were doing it, because Houston, we have had a problem with space. We've had a problem not with NASA and its wonderful skills in exploration, or ESA and the wonderful work it's done, or the Chinese, or the Russians, or indeed the work that has been going on using former military rockets, but actually the fact that we haven't even been able to break out of the idea that we must always go to space by ground-based rocketry. And it was one of the things that really annoyed me during the period when the X Prize was happening, that the ideas of how technology works hadn't been understood and how you can apply new technologies hadn't been understood. This car that you see here was invented in 1927, and it was the world's first petrol-electric car, patented. And it worked very well. It was highly fuel efficient. But because of the way other factors in the economy were working, the price of fuel coming down continuously, the Second World War leading to synchromesh gearboxes and cheap diesel engines that were highly efficient, although it was used on London's buses, this petrol-electric system, it was never developed into a car. So much so that the Science Museum relegated it to Swindon in the 1980s. And they relegated Swindon, and when I wrote to them very angrily, because my grandfather invented it, they said there will never be a use for petrol-electric technology again, and I have the letter. However, people at Toyota thought they were wrong. And 70 years after that car was built, technological change and the ease of building electronic components to make systems like this work in a mass market led to the Toyota Prius. And I think the same is true of what Bert did. It was NASA who were ahead of their time. It was NASA who inspired us in this project in a way through the X-15. The X-15 was an incredibly clever and interesting project, and yet it had some failings. Bert worked at the end of this project at Edwards Air Force Base, and a friend of his was killed flying an X-15. And that was what made Bert think throughout the beginnings of the Spaceship One project that tackling the re-entry issue for suborbital flight in a way that was safe would be the commercial breakthrough to lead to a commercial operation eventually in the end. And of course, the idea was a big idea. The idea of the X Prize, which was Peter Diamandis' idea, really did do what the old prizes of the 18th, 19th and early 20th century had done for technology. The X Prize, it was $10 million. There are people in the scientific and industrial community who scoffed at the X Prize. They scoffed at Spaceship One winning it, and they scoffed at the idea that there was any point in suborbital projects of this nature or space tourism, because they didn't really see the connect between prizes, technological development, commercial development, regularizing things so as people can learn to do it, inspiring things, and also they didn't think about all the spin-offs. So those in 2004 who said that this was a waste of time, I think will be proved wrong over the next few years. So the engineer came along to win the prize, and what an engineer he is. They won this prize, as I said, for the $30 million that was spent, and they inspired us to invest in a business. The entrepreneur who came along had his own ideas about what he wanted to see happen, and he didn't know if it was achievable. The original picture Richard would have been pictured with when we did the project, when we announced the project in 2004, would have actually been a thing that looks like Spaceship One and White Knight One. Because our first research told us the easiest way to commercialize this was to simply take it forward and simply build a Spaceship 1B, take 2 people into space, get some money in the bank, and then we were going to build something like this. But as it turned out, luckily our customers told us that was a mistake, and they led us to take a much braver move. People who wanted to fly to space, the customers, and here are some of them in New York recently, the customers told us they wanted to experience weightlessness in space. And because they told us that, we needed to build a much bigger spaceship. And because we needed to build a much bigger spaceship, and because we were going to take a much bigger industrial risk, we needed to start thinking about a lot of other uses for that spaceship apart from simply space tourism. So they made us leap straight to where we would have eventually got. Now, those customers also proved the point that some people had worried about. They proved the point that actually, if you're 50 and you're reasonably healthy, you don't need to be that fit to be able to go to space. And we proved that very early on in the program by simply taking them and putting them through a centrifuge. And even Professor James Lovelock, who's 89 years old, going to be 90 soon, Professor James Lovelock has managed to do this and pull his G's. So we began construction of the spaceship project in late 2006. And we feel it's been going very slowly, but actually I think by the standards of industrial projects of this nature, it's gone pretty quickly. That was Mothership Eve, in fact, having the wings put on it only a month and a half before we unveiled it at the end of July. That is the largest carbon composite structure ever built in human history. At 140 foot long as a single piece of composite, which is what the wing spar is, it is the largest single piece of composite ever constructed. This is Spaceship 2, which you saw in the film. And this is Bert in the cabin demonstrating that even a man who's 6'3" tall is going to be able to get into this and enjoy moving around in a very roomy cabin. And this, of course, is the finished product. Now, the flight path that you saw in the movie just now, which is illustrated here, is a really interesting flight path. Because if you're going to build a White Knight 2 that is capable of launching Spaceship 2 and giving those people their experience, you're also capable of launching Spaceship 2 with science and payload on it to allow microgravity experiments to be done. But beyond that, if you can build a White Knight 2 that's big enough to do that, then if you ask Bert, which we did, to build an open architecture so as we put other things on it, you can begin to think about other businesses. We can put an unmanned, we could ourselves build using our Rocket Motor 2 technology and using basically a lot of components out of the spaceship. We could build an unmanned vehicle which could get 100 kilograms into low Earth orbit at about 300 kilometers up. But White Knight 2, with its 17-ton capacity to 50,000 feet of payload, somebody else who's cleverer than us, who's got rocket motor technology already, either solid or liquid, could build a two-stager, which we believe could get at least 200 kilograms to up to 800 kilometers up in low Earth orbit. So White Knight 2 is a really, really exciting aircraft with lots of scientific and industrial applications in space, and quite a lot more within the terrestrial world as well. And here is White Knight 2, proudly finished in the summer of this year, with Bert and Richard standing beside it, about to begin its first ground test before the flight testing starts in a few weeks' time. So, what was our investment model, and what is the investment opportunity that Virgin Galactic presents? I think the interesting thing about Virgin Galactic, and the way we looked at it right from the beginning, is the way that when we go out for a second round of financing on this project over the next year or so, we will also explain to potential investors, some of whom we're now going to because they've approached us. But we understood quite early on, we didn't say it publicly quite early on, it's only been the last year we've really begun to get into this area in terms of the way we presented this project. Tourism was our first available market, and the tourists told us some really interesting things that led us to realize that the science and trading markets with this vehicle were going to follow pretty quickly. Those multiple development opportunities were worked in from the beginning because we never knew if we'd ever get FAA permission to eventually get to that position of being able to fly into space with those people. Therefore, let's think, if we can, about how we could use the White Knight 2 and the technology if we failed to ever become commercial with the space tourism market, that first available market. However, as things developed, the customer numbers and those high margins suggested that we could make a profit in year one of commercial operation just from the opportunity of space tourism, and we could actually, within 2 years of launch, in the terms of commercial launch after 2010, we could possibly go to an IPO with this business in the future. So the project is now reaching the maturity level with it as we go into the experimental test flying phase that will allow us to consider external investment, clearly once the current financial situation the world is facing has moved on somewhat. We're also thinking now about the other things that we'll be able to do in the future. Virgin Galactic is the business at the moment, but this is already spawning in the mind of Richard Branson the businesses that will follow on: space tours, science services, cargo, and of course, eventually, Virgin Atlantic's interest in this project, and the reason they've been so cooperative with us, with a lot of pro bono work that their engineers have done with us, the pilots who they've allowed to commit to the project, to get involved in both centrifuge developments, get involved in the specification of the cabin and the cockpit. Virgin Atlantic see a future whereby this could be the beginnings of a Spaceship 4 or Spaceship 5, which could get you from London to Australia, or in fact, Glasgow to Australia in 3 hours rather than the current 27 hours. So we really believe that Virgin Galactic will be coming to a desert near you pretty soon. We think that with the current program we've got and the great work that the state of New Mexico are doing at Spaceport America and the beginnings of construction that later this year, Spaceport America, which has been again designed by a British company, Foster & Associates, Lord Foster's company, the design of Spaceport America is not only complete, it is now moving to a construction phase. It will be ready for us. But the other advantage of this system is it will be able to tour it around the world. So we will be able to do summer flying in Lossiemouth. So bring on those CUBE satellites from all the universities in Britain, and hopefully we'll be carrying them from Britain in 4 or 5 years' time. In Sweden, we're already pretty advanced with the work on preparing for the opportunity to bring Virgin Galactic to Kiruna. That's where we could not only take our space tourists up into the Aurora Borealis, but at the same time, we could do small sat launches from there into polar orbit. And from there, because of the capacity that we have in White Knight 2 to carry the system that we would launch to any location with a 2,800-mile range, we could also, from New Mexico, get to orbits in other parts of the world, and we could work from any long runway to do equatorial orbits as well with payload, as well as doing the kind of science work I've been talking about. Thank you very much.